Hello everyone. In this new series, we are going to learn Etab software. So in this video, we are going to learn some overview of Etab structure and what is the structural analysis and design. Structural analysis is a branch of solid mechanics which use simplified models for solid like bars, beams, and shells for some engineering decisions making. Its main objective is to determine the effects of load on the physical structure and their components. In contrast to theory of elasticity, the model used to structure analysis are often differential equations in one spatial variables. Structural structures object to this type of analysis include all that must withstand a load such as building, bridge, aircraft, ships. Structural analysis uses ideas for applied mechanics, material science, and applied mathematics to compute a structural deformations, internal forces, stresses, support reaction, velocity, and acceleration, stability. The result of analysis are used to verify structures fitness for use, often precluding physical test. Structural analysis is thus a key part of engineering design of structures. And you know that there are two types of structural analysis, that is one is force method and another is displacement method. So we are going to see how is the structural analysis done. So before structural analysis, some basic fundamentals we have to know, that is manual calculations for calculating shear force and bending moment. See, let's assume a simply supported beam AB of span 6 meter carries 2-point load as shown in figure, and the question is to draw shear force and bending moment for the beam which is connected between the 2 points A and B, and the loads given at point C is 30 kilonewton and at point D 60 kilonewton at a constant distance of 2 meter. Okay, that the total distance is 6 meter and the distance between the support and load is 2 meter. Then next distance between two loads is concentrated loads are at point C and D is 2 meter, and the next last one is distance between D and B is 2 meter. Okay, here are some sample calculations for this question and the solution. Okay, you can calculate that support reactions of Ra and Rb, it comes to 90 kilonewton, and the movement summation of movements you can calculate, that will come. And if you know very if you know the calculations, then you can calculate easily. Then Ra is come to be 40 kilonewton. Then for the shear force calculation, you can see the shear force diagram is on your screen like this. The shear force diagram will come for this beam as connected to A and B. Okay, then next is bending moment. The bending moment is calculated for this beam and it will come at point C is 80 kilonewton meter and for D is 100 kilonewton meter. Okay, the units you have to know, kilonewton meter and kilonewton meter. Okay, for the moment, see the finally we got the shear force diagram and bending moment diagram for this beam. Okay, it is 40 kilonewton. It's carry forwarded to 40 kilonewton. Okay, then it is coming 10 kilonewton. Similarly, carry forwarded to point D, it's 10 is come to 50. Then again it is 10 minus 15. Okay, and finally it is 0 at a point. Then similarly for bending moment, the bending moment diagram comes in a positive. Okay, so at point C it is 80 kilonewton positive kilonewton meter, and at point D 100 kilonewton meter is positive. The objective to calculate this data. Assume M20 grade concrete and Fe415 steel. Okay, this M is mixed and 25 is grade. This compressive strength of concrete, and F is steel and tensile strength of the steel. Okay, then finding the shear force and bending moment for singly reinforced concrete beam with the following clear span of 4 meter. Okay, then the width of support is 230 mm. Okay, that is 0.23 meter. Okay, then the live load is given is 4 kilonewton meter. And then the manual calculation is like this: the effective depth is equal to clear span divided by 20. Okay, this formula you will get in IS 456 2000. Okay, then self weight, that is nothing but dead load, the volume into density. Okay, the density of concrete is 25. Then you have to calculate the factor load, so we have to multiply with 1.5 factor of safety with our dead load plus live load. Okay, it will come as 8.15625 kilonewton per meter. Then the shear force is W into L divided by 2. It will become 17.17 kilonewton, and the bending moment similarly it will come at the bending moment formula is given here for a concentrated load W divided by 8. Then it will come at 18.07 kilonewton meter. Okay, hope you understand this is the manual calculation for structural analysis.